now we are once again live. So I'm joined today. We're going to talk a little bit about some of the keynotes for SpringOne platform. And this is Rossen and Stephane. And they're working very hard on some things that I think is very important. And I'll let them introduce themselves, and then we'll talk a little bit about Reactive and some of the new stuff that's coming in Spring Framework. So how about we start with Stephane?
Hey, so I'm the project lead for Reactor and currently working in Pivotal in engineering since last year. And I'm working closely with the Spring team to make sure we manage to successfully transition to Spring 5 for our reactive story. And we're making our best efforts to have a close collaboration on the need for Reactor, which is going to be a dependency for Spring 5.
And I'm Rossen. I'm a developer on the Spring Framework team. I focus on the web side of things, which is primarily Spring MVC, also WebSocket messaging. And for the past year, I've been working with Stephane and the web team to develop a reactive story for Spring Framework 5, the ability to create reactive web applications is what we're focusing on.
So let's talk about that word. So this isn't unique to the Spring conversation. Lots of people are talking about reactive and what that means. So just for the listening audience who may not be following that conversation, what's happening? What's the motive for this kind of new style of architecture?
Well, I think if you talk to Stephane, who I'm sure will give you perspective as well, and he's been talking about this for many years now. The Reactive project has been around for a number of years, but really what's pushing a lot of this into the mainstream and where the development with Reactor is coming to a level of maturity and a lot of other developments taking place in the meantime with the reactive stream specification and ReactiveX style programming, is that a lot of the modern style applications, cloud native, there's a lot of latency involved, and as you begin to deal with asynchronicity, you find that the old assumptions that we've been using for 20 years with the Java and the servlet container model and the servlet API, with a thread pool and each thread basically processing a request, are no longer making it easy to deal and build scalable applications that scale efficiently for that. So in my mind, this is the big driver. There's a large increase of latency in what applications have to do. If you think about microservices and talking to other services and then doing the kind of scatter-gather style operations, where the imperative style of programming is no longer a good fit for doing that, and you find yourself dealing with asynchronicity in ways that aren't making it very easy.
Because the new style of architecture sort of assumes that you're going to deal with these distributed systems where you've added inherent network in the middle, and how are you going to deal with all the problems that you just sort of outlined?
Yeah, I mean, it really comes down to, in the past, we've been able to deal with asynchronicity here and there, maybe make a database call or something else. It's more of the exception rather than the rule. Whereas now what we're seeing is where asynchronicity is really no longer the exception. It's becoming more of a starting point. And then the other side to this is that with cloud native applications, you really want an efficient use of resources. And as we know, with horizontal scaling and generally with thread pools, achieving larger levels of scale requires a lot more resources.
So maybe go into, and we were having a conversation with Stephane earlier about some of the stuff that you're getting, some of the thought that's going into that implementation to be able to handle these scenarios.
That's right. And actually, you know, every time you have an asynchronous boundary, you have to deal with the message passing concern. And we have now today a mature framework to work with this message passing concern, especially what we want to deal with, which is back pressure. And what is it all about? It's simply about not asking more data, leaving the data at its original source location until we have enough capacity to process it. And that's the capacity model we aim for, because today we use cloud-ready architecture where we can make the most of mutualized resources. And so if you can't predict, you don't have a strong capacity model for each of your microservices you deploy, you're not going to make the most of your infrastructure. And in a classic thread pool container model, that's actually the kind of issues you can face with this architecture. So we deal with that at the reactor level on the programmation model directly. So you can actually use Reactor to deal with all these kind of message passing issues in a very, very direct way. We don't involve like external message queues or something, some other technology. It's just plain in-memory message passing with all the back pressure stuff worked for you. And you have a set of operation already made, heavily inspired by a mature model like reactive extensions.
So the way things are evolving with the Spring framework, we're talking about having the ability to do the message passing as part of Spring without any external queue. There's not like another sort of message queue you're going to pass things through.
Yeah, it's a kind of event-driven model that's been around and has been done in places like trading applications, the domain of applications that need to achieve a kind of level scale that's been there for a while. But now, with non-blocking and asynchronous applications, this is really, you know, once you go down that path, those are the kinds of issues you begin to deal with. And you want to efficiently pass messages and deal with streams of data and apply back pressure, as Stephane talked about. And there's also a specification in all of this. There's the reactive streams specification, of which Reactor is an implementation. That spec is also going to be in Java 9. So you could say that this is actually probably the first implementation in Java, direct implementation of the Reactor Stream spec, and the Spring Framework is making major strides towards supporting that for building Spring applications. Really, kind of the vision for reactive streams is that many different libraries that are going to provide non-blocking functionality, whether it's Mongo or Couchbase, the Spring Framework, whether it's the even Tomcat or Jetty or Netty, at the runtime level, exposing asynchronous functionality with back pressure. You want that back pressure to work across, from end to end across these libraries. That's kind of the big prize, the big goal.
So just for educating myself, who writes that spec, the reactive stream spec?
So actually, it's been a cross-company effort. We've been working from Pivotal. I've been actually involved in the specification, but we've been working with Netflix and TypeSafe now, Lightbend notably, and we made sure actually there is a TCK all this framework can conform to, and that's an important step as well, because we needed to verify a behavior. You know, we have an asynchronous behavior actually described by the specification. When can you send messages? What is the back pressure? If you don't receive this back pressure, what do you do? All this kind of behavior needed testing, and we make sure with this protocol, by working with the TCK, we actually can share information between these frameworks. Each of these companies might have developed, like Akka, for instance. We can discuss between Akka and Reactor because they do implement the same protocol, and that's an important step also. I think quite a game changer in the space of asynchronous processing.
So I think there's an interesting sub-story to that as well. I mean, we in Java, we're very used to the the JCP process and the Java specification process. And here is an example that is a complete outlier in the sense that just a bunch of companies that were at the forefront and trying to do something came together and produced something that was useful enough that it's actually being adopted in Java 9.
So if I'm a developer and I'm hearing about this stuff, like how do I figure out when to apply this, or when should I use the old paradigm? Do you have any kind of tips and tricks for how someone should think about, be thoughtful about adopting this?
Yeah, so this is the big question that's actually very difficult to answer in one way or definitive way. There is no precise measure, and from the beginning we knew that we didn't want to be in a position where we have to say, this is the new way, there is the old way, and you have to go from one to the other, because it's actually not the truth. It's not exactly the case. Really, the good way to see this is a kind of scale. On one side of the scale, you have the relative simplicity of imperative programming with blocking, which sounds like a bad word these days, but it's a simple way to write logic, and it's perfectly suitable for many applications, and will continue to be. On the other side of the scale, you have increased latency and asynchronicity, the need to be more efficient in using resources, and these are all good things, but they come with a certain cost. You have to change your programming model. You have to do things that are a little more complex to work with and to debug, and we certainly think that over time it's actually going to become easier and more mainstream. But in the meantime, it's really a kind of scale, and you have to decide where you belong on that scale. How much latency there is in your application, how efficient do you want resource utilization to be, how much memory footprint, horizontal versus vertical scaling. These are difficult questions to answer. It's a very much an application-specific thing, but one thing there's no question about is that these are important trends that everybody should learn about, whether you're going to use them today or tomorrow or not.
Absolutely. So I'll give you guys a chance to make one last word of wisdom, and then I think everyone who wants to learn more about this should come see the keynote at SpringOne Platform. You have any last words?
Yeah, go ahead, Rossen.
Yeah, who should go first? I would like to point out that the keynote, we really worked hard to explain these issues. We've been talking about them for some time, and we think we have found a good way to talk about them and to explain them, and that's one of the benefits that has always been of the Spring Framework, is that we come to these questions and we find ways to make them easy to adopt and to understand, which is a big part of adoption. So we're excited, for the keynote, and also we have sessions where we will continue and expand. So really, if you want to get your mind wrapped around this topic, and there are many other great topics. I'm personally involved with the web track, and we have a lot of exciting sessions this year, as all years, and there's always something new to pick up. So please come to Las Vegas.
I look also forward to the sessions. There are increasing and unusual number of reactive sessions, I'd say, and it's important, I think, to come and see the lengthy content about this topic, because it's driving change, and I think you will face the question whether or not you choose to use that path yet, but that's important to understand the driver for this change and how it applies to you in general. And also I would add, it's very interesting for us to be able to collect feedbacks as well, as we are relatively early phase in this project, especially with Spring 5 Milestone 1 coming soon. We are eager for feedbacks, and we look forward to the kind of issues you will face when you start using this thing. The user experience and the pragmatism is always very central to the Spring engineering team. So that will be an interesting discussion if you have any kind of feedbacks, just let us know, and it's always better with a drink, I suppose.
Yep. Perfect point. Perfect point. That it is the place to meet and talk with Spring engineers, and it's the place where many great ideas, including Spring Boot, were born. We hope to continue that trend.
And always better with a drink. I'll see you guys in Vegas. I learned a lot. Thanks a lot.
Thank
Bye-bye.
you.